Welcome to the deep dive. Today, we're diving into the world of robotics and AI, but more specifically, the work of Unitree Robotics. We've got this super interesting conversation between the Unitree CEO, Xingxing Wang, and Guanya Shi, who's a professor at CMU's Robotics Institute. We're going to unpack it all. Think backflipping robots. Robots running super fast. Okay, maybe not cheetah fast, but still impressive, so get ready. Things are going to get really cutting edge.
You know, what's fascinating to me is that Unitree is taking all this theoretical stuff and making it a reality, and they're doing it so fast.
It's kind of mind-blowing, right? Wang, the CEO, he explains how Unitree started. From his dorm room in college, he was just tinkering with robots back then, and now his company owns like 60% of the global market for quadruped robots. And get this, he started with only $3,000. That's it. A tiny investment turned into a robotics empire. That really shows what you can do with vision and determination.
Oh, totally. Yeah. It really shows the power of thinking big, even if you're starting small. But what I find even more intriguing is that Unitree isn't just focused on building robots. They're really invested in AI, too. Most of their robots run on AI.
Yeah, and that's a huge shift from, traditional robot programming, right? Like, instead of just following instructions, these robots are learning and adapting.
Exactly what we're talking about.
Yeah.
A whole new level of sophistication. And you can see it in their achievements. Their humanoid robot was the first one to do a backflip. A battery-powered full-size robot doing a backflip. That's a first.
A backflipping robot. That's pretty impressive. Well, what's the practical use of that? Is it just a cool trick, or does it show some deeper level of agility?
Well, it shows just how advanced they are in terms of balance and motor control. And it's not just backflips. This robot can run at 3.3 meters per second. To put that into perspective, that's faster than some of the most advanced robots out there.
Wow, that's fast. So it seems like they're not just doing flashy stunts, they're building robots that can move really fast and precisely. What else are they working on?
One thing that really stood out to me was a demonstration of a robot navigating an obstacle course. I mean, a really complex obstacle course. It had to move through tight spaces, climb over obstacles, and even open a door. And it did all of this really skillfully.
So they're teaching robots to think on their feet, to adapt to unexpected challenges. It's a big step towards robots being able to function in the real world, not just in a lab.
For sure. And this is where it gets really interesting. Unitree has developed an affordable 3D LIDAR system.
Okay, this LIDAR system, it could be a game changer. Imagine giving robots the ability to see in 3D at a low cost.
Yeah.
All sorts of applications open up, even for your house.
You got it. This has huge implications, not just in robotics, but in fields like autonomous vehicles, drones, and even consumer electronics. One innovation leading to endless possibilities. But let's bring in Guanya Shi's perspective, especially about AGI robots. Yeah, she makes a good point. The definition of AGI, it's still not super clear. It's kind of a fuzzy concept. But most people agree that AGI robots should be able to do lots of different tasks based on one model.
So it's not just programming a robot to do one specific thing. It's about robots that can learn and adapt to new situations, robots that can think for themselves.
Exactly. And she says that there are 3 layers of intelligence that are needed to achieve AGI.
Okay, I'm all ears.
The first layer is semantic intelligence, which is basically understanding high-level concepts and tasks. It's like understanding what instructions mean and figure out the best way to follow them. And she says, large language models are already doing this. They're getting better all the time.
So we're talking about robots that can understand what we mean, not just what we say, but can they actually put that understanding into action?
Yeah, that's where the second layer comes in. Physical intelligence. This is all about the robot's ability to interact with the physical world. Think about things like navigating, manipulating objects, and staying balanced.
Yeah, we take those abilities for granted. But for robots, it's incredibly hard. Imagine trying to program a robot to walk up stairs or fold a shirt. It's mind-bogglingly complex.
Oh, absolutely. And there's still a lot of work to be done there. She doesn't say it directly, but there's also a third layer, sensory intelligence.
Sensory intelligence, what's that?
That's the robot's ability to process sensory input, like what they see and touch, and then respond to that input.
Okay, so semantic intelligence is for understanding, physical intelligence for acting, and sensory intelligence for perceiving, like building a human brain.
Yeah, kind of. And each layer has its own challenges.
This is a lot to take in, but it's also really exciting, it feels like. We're on the edge of something big. But I have to wonder, does all this lead to AGI? What does Wang think?
Well, Wang says that the biggest challenge right now for humanoid robots is developing advanced AI, especially general-purpose models that can be used in all kinds of situations.
But is he optimistic about the future? I mean,
Oh, yeah. He's very optimistic. He thinks there will be a breakthrough, maybe even by the end of next year. And he predicts that in the next 3 to 5 years, we'll start seeing practical uses for humanoid robots. And that's just the beginning. He thinks these robots will change industry and society in the next 5 to 10 years.
wow, that's not that far off. Sounds like the robot revolution is coming. What do you think? Exciting or scary?
Honestly, a little both. The potential is huge, but there are risks too. We have to approach this new era carefully and make sure we develop this technology responsibly and ethically. But that's another conversation.
You're right, we could probably do a whole deep dive on the ethics of AGI. But for now, let's keep exploring. The world of robotics, there's so much more to talk about.
Yeah, it's a wild time to be in this field. It seems like every day there's something new and incredible happening.
Yeah.
But going back to AGI, what does it even look like? I mean, Shea says the definition is still fuzzy. What are we actually looking for in an AGI robot?
That's the big question, right? How do we know when a machine is actually intelligent and not just really good at following instructions?
Well, one key characteristic is cognitive flexibility. An AGI robot should be able to adapt to new situations, not just follow a set of pre-programmed rules. It should be able to solve problems in creative ways, and maybe even learn from its mistakes.
So like a robot with common sense, a robot that understands why it's doing something, not just how to do it.
Exactly. And that's why those 3 layers of intelligence she's talked about are so important. Semantic intelligence lets a robot understand the context of a situation. Physical intelligence lets it interact with the world. And sensory intelligence helps it perceive and respond to the environment.
Each layer builds on the last one to create a more complete kind of AI. But let's talk about Unitree again. They're clearly pushing the limits of robotics. But are they actually trying to achieve AGI?
They don't say it outright,
Hmm.
but you can see hints of it in their work. Their focus on AI training, especially something called end-to-end learning, suggests they're moving toward more autonomous and adaptable robots.
End-to-end learning, what is that? And doesn't that mean giving robots a lot of freedom? What about safety? How do you make sure they don't go off the rails?
It's a balancing act, for sure. End-to-end learning is about training a robot to do a task directly from sensory input without relying on pre-programmed rules. It's like teaching a kid to ride a bike by letting them figure it out themselves, instead of giving them step-by-step instructions.
So it's more like learning by doing.
Exactly. It's more hands-off,
Yeah.
but it's definitely harder. You need tons of data, powerful algorithms, and a lot of patience. But the payoff could be huge. You could let robots learn really complex behaviors and make them much better at handling real-world situations.
Okay, I see why Unitree is so interested in this approach. But for our listeners out there, why should they care about AGI robots? What does this have to do with their lives?
Think about the potential. AGI robots could totally revolutionize industries. Manufacturing, healthcare, transportation, elder care. Imagine robots helping with surgeries, providing companionship to people who need it, or even exploring dangerous places. The possibilities are incredible.
So it's not just about robots doing cool tricks. It's about robots making our lives better, easier, safer, more fulfilling. But there are potential downsides too, right? What about robots taking people's jobs? Or what about safety concerns?
Those are important points. Any technology this powerful comes with risks. We have to be careful to develop AGI responsibly, with transparency, accountability, and safety as top priorities. We need to talk openly about how this technology will affect society. Job displacement is a real issue, and we have to make sure that everyone benefits from AGI.
It's a lot to think about. It's not just about the tech itself. It's about how we use it and what safeguards we put in place. Sounds like we need another deep dive just to talk about the social and economic impacts. But let's go back to something Wang mentioned that really struck me. The challenge of battery life in robots. That's something we don't often think about, but it's a big limitation.
It is, for sure. Even with everything robots can do today, they can only do it for so long before they need to recharge. That's a problem if we want robots helping around the house or working with people in factories.
So what's the solution? Better batteries, more energy-efficient robots.
Those are definitely things people are working on. But they're also exploring other ideas, like wireless power transfer. Imagine robots that charge wirelessly as they move. And there's research into robots that can harvest energy from their environment, kind of like living things.
So thinking outside the box, finding new ways to power these incredibly complex machines. What about Wang's thoughts on the overall industry? Anything stand out to you?
His insights on hardware and software were interesting. He stressed that it's a systemic challenge. You can have the most advanced AI in the world, but if the robot itself is clunky or unreliable, it's not going to be very useful.
Right, it's like having a super fast computer with a terrible keyboard. It's
Yeah,
just not going to work. You need both the cutting-edge hardware and the powerful AI.
exactly. And Wang made another interesting point about how Unitree sells their robots. They sell to all kinds of customers, researchers, educators, businesses, anyone really. And what's interesting is that they're willing to sell to pretty much anyone who wants to buy the robots,
Mhm.
no matter their background or what they plan to do with them.
That's a bold strategy. It's kind of like the Wild West of robotics right now. Everyone from hobbyists to huge companies is getting involved. But it also shows how quickly this technology is becoming accessible. It's not just in labs anymore, it's in the hands of everyday people.
And that's exciting, but also potentially worrying. It raises questions about regulation, safety, and ethical use.
Mm.
Who's responsible for making sure these robots are used safely? It's a complicated issue with no easy answers.
It's like we're at a turning point. The amazing potential of robotics is running headfirst into some real concerns about the consequences. But let's get back to Xi's ideas about AGI robots. He seems optimistic about large language models helping with semantic intelligence. But what about the other two layers? Physical and sensory intelligence. Where are we with those?
She admits that physical intelligence, a robot's ability to move around and interact with the real world, still needs a lot of work. We've seen some impressive robots from companies like Boston Dynamics and, of course, Unitree. But they're still a long way from being as skillful and adaptable as humans.
It's like the difference between a robot walking on a flat surface and a robot climbing over rocks or squeezing through a tight space. The real world is messy and unpredictable, and robots need to be able to handle all that.
Exactly. And sensory intelligence has its own challenges. Robots need to be able to perceive the world accurately and reliably. And that means having advanced sensors and algorithms that can make sense of all the data.
Think about all the subtle cues we pick up on as humans. Facial expressions, body language, tone of voice. Replicating that level of understanding in a robot is a huge challenge.
It shows just how complex the human brain is
Yeah.
and how hard it is to copy that in artificial systems.
But even with all these challenges, it sounds like there's a lot of optimism. She seems to think we're not far from some big breakthroughs in AGI.
Right. He suggests that in the next year or two, we might see a big leap forward in general-purpose AI models that could be used in tons of different robots. And Wang agrees. He thinks we'll have commercially viable humanoid robots within 3 to 5 years.
Wow, so the robot revolution is about to really take off. Let's zoom in on something specific that Wang talked about. Unitree's really cheap 3D LiDAR system. Why is 3D LiDAR so important? Why should people care?
Great question. 3D LiDAR stands for light detection and ranging. It's basically a way for robots to see their surroundings in 3 dimensions. It works by shooting out lasers and measuring how long it takes for them to bounce back. This creates a super detailed 3D map of the environment.
So it's like giving robots superhuman vision. They can see depth and distance perfectly.
Exactly. And the fact that Unitree made a 3D LiDAR system that's so cheap around $1,000 is a game changer. This technology isn't just for fancy labs and big corporations anymore. It's something that small companies, startups, even hobbyists can get their hands on.
So cheaper 3D LiDAR means more people can play around with robots and come up with new ideas. It could lead to a wave of innovation.
Exactly. Think about what this could mean for self-driving cars. Drones, home automation. Imagine robots that can navigate your house perfectly. Drones delivering packages with pinpoint accuracy. Self-driving cars that can see and respond to their surroundings even better.
3D LiDAR is like a key that unlocks a whole new world of possibilities. But let's talk about the AI training that Unitree is doing. They showed off a robot navigating a crazy obstacle course and even opening a door. What can we learn from that?
The focus on practical real-world skills is impressive. They're not just training robots to do simple tasks in a lab. They're pushing them to adapt to difficult and unpredictable situations.
It's like they're teaching robots to improvise and think on their feet. That's a crucial step towards robots that can actually function in the real world.
Absolutely. And the robot opening a door is a great example because it needs fine motor control and an understanding of how objects work. It's not just about strength. It needs a level of dexterity and finesse that's hard to program into a robot.
And remember, Wang said most of their robots are running on AI now. It's like they're building intelligence right into the robots themselves, not just adding it on as an afterthought.
It's a sign of where the industry is going, moving away from old-school pre-programmed robots and towards a future where robots can learn, adapt, and even make decisions themselves.
Okay, so we've got Unitree pushing the limits of robotics and AI researchers like Guanya Xi figuring out the mysteries of AGI, and technologies like 3D LiDAR opening up all sorts of new possibilities. It feels like something big is about to happen. But what about us? Where do humans fit into a future with intelligent robots?
That's the key question. As this technology keeps getting better, we have to think about the ethical and societal implications. How do we make sure robots are used for good? How do we make sure they help us instead of replacing us?
It's not about robots versus humans. It's about finding ways to work together. And that means thinking carefully about things like job displacement safety protocols and even the potential for robots to be used for harmful purposes.
Right. We need to involve policymakers, researchers, industry leaders, and the public in this conversation. We need to be proactive in shaping the future of robotics and making sure it reflects our values and goals.
It's not just about the cool tech, it's about the choices we make and the future we build. That's a powerful message. And it brings us back to Xi's 3 layers of intelligence for AGI robots.
Let's dive into that. First up, semantic intelligence. She describes this as the ability to understand high-level concepts and tasks, like being able to figure out what instructions mean and how to follow them.
So not just blindly obeying commands, but actually understanding the intent and reasoning behind them.
Exactly. And she points out that large language models like the ones that power chatbots and virtual assistants are making big strides here. They're getting really good at understanding natural language and figuring out what complex sentences mean.
So robots that understand what we mean, not just what we say, that's huge. But how do we get from understanding language to actually doing things in the real world?
That's where physical intelligence comes in. This layer is all about a robot's ability to move and interact with its environment effectively. Things like walking, picking up objects, using tools, staying balanced. These are all really difficult for robots.
Right, understanding pick up the cup is one thing, but actually coordinating all the muscles and joints to do it smoothly and without spilling is a whole other challenge.
Exactly. This is where robotics control theory and even biomechanics come in. Researchers are developing super sophisticated algorithms and control systems that let robots move with more precision, agility, and grace.
It's like we're trying to teach robots to dance, to move through the world with elegance and fluidity. But it's not just about looking good, right? It's about functionality.
Absolutely. A robot that moves well is also going to be more efficient, safer, and less prone to mistakes. And the physical design of the robot, its shape, its weight distribution, the materials it's made of, all play a big role here.
So physical intelligence is all about connecting understanding to action, connecting the robot's mind to its body. But what about the third layer, sensory intelligence? What does that involve?
Sensory intelligence is the robot's ability to perceive and interpret information from its environment. It uses a whole bunch of sensors, cameras, microphones, tactile sensors, and more to gather data about its surroundings.
It's like giving robots a really detailed picture of the world. They can see, hear, and even feel what's around them.
Right. But the hard part is processing and understanding all that data. It's not just about collecting information. It's about making sense of it, finding patterns and using it to make decisions.
Like the difference between seeing a red light and understanding that it means stop. Sensory intelligence turns raw data into useful knowledge.
Exactly. And this is where things like computer vision, machine learning, and signal processing come in. Researchers are developing algorithms that can help robots recognize objects, track movements, interpret sounds, and even understand human emotions from facial expressions and body language.
Wow, that's amazing. It's like robots are developing a sixth sense, a deeper understanding of the world. But how do these 3-layer semantic, physical, and sensory intelligence work together to create a truly intelligent robot?
It's like an intricate dance.
Yeah.
A beautiful symphony of perception, cognition, and action. Imagine a robot that's asked to make a cup of coffee. Semantic intelligence helps it understand what coffee and cup mean and what the steps are to make coffee.
So the robot has the recipe in its head. Now it needs to actually make the coffee.
Right. Physical intelligence lets the robot go to the kitchen, find the coffee maker, grab the pot filled with water, and so on. It's about coordinating movements, manipulating objects, and carrying out the steps.
So physical intelligence is the robot's body putting the plan into action. But how does it know what to do at each step? How does it avoid bumping into things, spilling water, or messing up?
That's where sensory intelligence comes in. The robot uses its sensors, its cameras, tactile sensors, and so on, to keep track of its environment and adjust its actions. If it gets too close to something, it can change its path. If the coffee pot feels too heavy, it can adjust its grip.
Sensory intelligence is like the robot's feedback system. It's constantly giving it information about the world and letting it make corrections in real time. It's like a conductor leading an orchestra, making sure everything is in sync.
That's a perfect analogy. It shows how important integration is. These 3 layers of intelligence aren't separate. They need to work together seamlessly to create a truly intelligent and capable robot.
It's like a team of experts, a linguist, an athlete, and a detective, all working together to solve a problem. But let's talk about real-world applications. Wang mentioned that Unitree is already selling robots to lots of different customers. What are some of the most exciting or surprising ways people are using these robots?
One area that's really interesting is using robots in dangerous places. For example, Unitree's robots have been used in disaster relief efforts, inspecting damaged buildings and searching for survivors in places that are too dangerous for humans.
So robots are becoming our first responders. They can go into dangerous and unpredictable situations and help us out.
Exactly. And there are other uses in industries like mining, oil and gas exploration, and even nuclear power, where robots can do jobs that are too risky or difficult for humans. They can check pipelines, monitor radiation levels, and even fix equipment in hazardous environments.
Robots are like our fearless explorers, venturing into the unknown and doing things that would put human lives at risk. But what about applications that are closer to home? What about robots in our daily lives?
That's where things get really interesting. We're starting to see robots being used in homes and businesses. For instance, there are robots that can help with things like cleaning, cooking, and even providing companionship to the elderly.
So, robot butlers and robot friends. It sounds like science fiction is coming true. But let's be realistic, there are also concerns about the impact of robots on jobs. What do you think about that?
It's definitely something to think about. As robots get more capable and cheaper, they might take over some jobs that humans currently do. But it's important to remember that throughout history, new technologies have often created new jobs and industries.
It's not always a case of robots versus humans, right? It's about adapting and evolving.
Exactly. And it's crucial that we invest in education and training programs that prepare people for the jobs of the future. We need to make sure people have the skills and knowledge to succeed in a world with more and more robots.
It's not just about building robots. It's about building a future where humans and robots can work together successfully.
Yeah, it's all about finding ways for humans and robots to work together, combining our strengths. But Wang also talked about how he got started in robotics. And it's a pretty inspiring story. He basically built his company from almost nothing, just a tiny investment and a whole lot of passion.
Yeah.
What do you think that says to people out there who want to be entrepreneurs and innovators?
It's a real underdog story, right? Starting with just $3,000 and a dream, and now he's running a company that controls like 60% of the global market. It's proof that you can turn passion into success. What's the lesson there?
It shows that great ideas can come from anywhere and that you don't need a ton of money to get started. If you're dedicated and you have a clear vision, you can achieve amazing things. Wang's story is a great example of entrepreneurial spirit and how innovation can shake up entire industries.
It's pretty amazing. And it's interesting that Wang started out in academia, right? As a professor, what advice would you give to students who are interested in robotics and AI?
I tell them to really focus on understanding both the technical side and the bigger picture. It's not just about coding and algorithms. It's about understanding how this technology can change our world. We need engineers and scientists who are also thoughtful and responsible about their work.
It's about seeing the forest for the trees, right? Using your skills to make a positive impact, not just building cool stuff for the sake of it. Speaking of big picture stuff, let's get back to this idea of AGI. One thing that struck me is that no one seems to agree on exactly what AGI is. It's still a kind of moving target. So how do we know when we've reached it? What should we be looking for?
Yeah, that's a question researchers are still wrestling with. There are tests like the Turing test, which measures a machine's ability to act like a human.
So if a robot can trick us into thinking it's human, does that mean it's achieved AGI?
It could be a sign, but it's not the whole story.
Yeah.
Some experts think AGI needs a deeper level of understanding, like being able to think abstractly, solve new problems, even be creative. It's about more than just imitating human behavior.
So robots that can think for themselves, not just follow a set of instructions, robots that can learn, adapt, and maybe even surprise us with what they can do. That's a pretty high bar. But for now, there are already lots of practical applications for robotics. And AI, Wang said Unitree is seeing a lot of demand for their robots in fields like manufacturing and logistics. Why do you think that is?
Well, robots are getting cheaper, which means more companies can afford them. And there's a growing need for automation, especially in industries that are struggling to find workers. Plus, robots are often better at doing jobs that are dangerous, repetitive, or need a lot of precision.
It's not always about replacing human workers, though, right? It's about finding ways for humans and robots to work together more efficiently, combining our strengths.
Exactly. Finding the right balance. And looking ahead, I think healthcare is a really exciting area for robotics. Imagine surgical robots that can help surgeons with complex procedures, making surgery safer and recovery faster. Or rehab robots that help patients regain movement after an injury. And of course, there's the potential for robots to provide care and companionship to elderly people, which is a huge need in many countries.
It's like robots becoming an extension of ourselves, helping us to live longer, healthier, and happier lives. But we can't ignore the potential problems. What are some of the ethical things we need to be careful about as we develop and use more and more intelligent robots?
Job displacement is a real concern, and we need to be prepared for it. As robots get more advanced, we need to make sure workers have the skills and support they need to adjust. There are also questions about safety and responsibility. How do we make sure robots are safe to use around humans? And who's to blame if a robot makes a bad decision that hurts someone?
It's a complicated set of issues with no easy answers, but it seems like the most important thing is to have these discussions now, before the technology gets so advanced that it's too late to change course.
I agree. We need to have open and honest conversations about the potential benefits and risks of AGI. And we need to work together to create ethical guidelines and regulations that ensure it's developed and used responsibly.
So it's not just about building robots. It's about building a better future for everyone. It's about using our intelligence, creativity, and empathy to create a world where technology helps humanity, not the other way around.
Well said. It's a future worth fighting for.
This has been a really fascinating deep dive into the world of robotics and AI. We've talked about a lot today. From the technical details of AGI to the ethics of intelligent robots, we've explored the possibilities and the risks, the breakthroughs, and the challenges. But as we wrap up, I want to leave our listeners with one last thought. The future of robotics isn't set in stone. We're all shaping it right now through the choices we make, the conversations we have, and the actions we take.
It's a future full of possibilities, both amazing and a little scary. And it's a future we're all part of.
Thanks for joining us on this journey, and until next time, keep exploring, keep asking questions, and keep diving deep.